Yes, Thomas, are you ready?
Yes.
Cool. So we can start. So hi everyone, Seb from Paris. Thank you all for joining for this new meetup today. It's a bit special as we are going to share this hour with students in the UK and France who participate in the the IBM Extreme Blue program. So this event will be held in the language of Shakespeare for everyone to be understood. But before I pass the mic to Chess and Thomas, a quick reminder, please use the WebEx chat to ask questions during the presentation. And depending on the time, we try to answer them at the end of each talk or during the talk, depending on the question. So now I'm going to pass the mic to Thomas, who will introduce the agenda, and then Thomas to Chess. I wish you all a very good meetup. Thomas, the mic is yours. And now I'm the timekeeper. So here we go.
Thank you, Sebastian. If you can move to the next slide.
Sure.
So it's becoming a habit now that we have a joint sessions with IBM Cloud Meetups in order to introduce the very cool project that your students have been doing for the summer. I mean, summer is a month of vacations, but not for all students. In order to provide some context, Francesca, whom we invited for this session, will first introduce the Extreme Blue internship program, which enables our students to create the great project that you will be seeing. Because it's a first, we have invited our teams from the UK to participate with us, and then we will have 4 projects that have been presented. Because there will be very little time for questions, we encourage you to use the chat, and also at the end of this meeting we will share a slide with all the contact information if you want to know more about each of the projects. Okay, but first, Francesca, what is the Extreme Blue program internship?
If you want to share your screen, you have the focus now. And you're in mute, so we can't hear you, Francesca.
Thank you, Thomas and Sebastian. So to talk about the Extreme Blue Technical Leadership Programme, as it's known this year, this is just not your average summer internship. So we work across a 12-week summer programme, and it's international. So we have teams from all across the globe. Originating from America, we've been running for 21 years. This year, we've had teams in Canada, America, China, and France and the UK. And in previous years, we've also extended out to Denmark, Germany, Romania, across the world. So we work with some of IBM's biggest clients. We have internal projects, we have external projects. And we don't let COVID stop us. So this year has been a programme like no other. We normally meet in the office, students share accommodation to really bond and get that experience of working all together. But this year we've been virtual. So unlike other companies who have maybe passed on their summer internship programmes, we have run and we've been on a virtual programme. It's been a great experience for everyone involved. It's had its challenges and its highlights, but I think we've really shown that Extreme Blue is a programme like no other, and it hasn't stopped us producing some really great work. We have forward-thinking students from all sorts of degree backgrounds, from standard computer science through to physics, chemical engineering, maths, history, etc., etc. They are learning constantly, not just about the working environment, but brand new program languages, technologies, meeting people from all over the business and working on groundbreaking projects. I think it's a testament to all the mentors, but all the students, how well they've worked this year. And I hope you enjoy the projects that they're going to share with you for this next hour. So I'm going to pass over now to Team Pace. So Team Pace is a UK team, and they've been doing some really groundbreaking work for the last 12 weeks. So I'll just hand over to Stephen and Team Pace.
Thank you. I'll just share my screen. Yeah. Okay. There we go. Hi, so we're Team PACE. I'm Tom, and I'm joined today by Stephen, Rachel, and Filipos. Whilst we come from very different disciplines, this project has really struck a chord with each of us, and we're incredibly proud to present what we've created to you today. So we are partnered with a charity called PACE, who are a charity that provide education, therapy, and support for children who live with cerebral palsy and other similar conditions. PACE itself functions primarily as a school, creating a space where their students can grow to thrive. Part of how they achieve this is by using a huge variety of assistive technologies in their day-to-day running. Assistive technology itself comes in many forms, but today we're going to talk to you about assistive switches. These switches provide direct control to electrical and digital devices for people who would previously be unable to access them. PACE introduces children to these switches at a very young age and then gradually progresses them to using more complex systems as they're able to grow and learn. This simple technology can then open the door for their students to learn to communicate, move themselves using something like a powered wheelchair, or control their immediate environment without assistance, all of which are tasks that otherwise would have been simply unachievable.
Throughout a child's time with the PACE Center, their switch systems are assessed by occupational therapists to determine their individual strengths and requirements. To perform these assessments in a child's home, an occupational therapist brings along a large collection of switches and interfaces to test, which, as you can see from the slide, is no small feat. The process where an occupational therapist sets up the equipment to assess a child can be very overwhelming. Many current devices are massively complex, too bulky, and have limited customizability options. The switches can also be intimidating to the children, resulting in them choosing to avoid using them. Furthermore, this project has revealed many pains beyond just those of the end users, the most substantial being the price, with many basic switches costing upwards of £100. This causes massive complications not only for charities with strict equipment budgets, but for families trying to build assistive systems in their homes. Overall, all stakeholders suffer from the outdated technology and difficulty in tracking the child's progress while using the products that are currently in the market.
To take in the market as it stands was actually quite startling. We realized early on that to democratize this area of technology, we needed to rethink all facets of the switch system from the ground up. That's why we have built an ecosystem, one that impacts the simplest way a switch is set up in the home and how it's used years down the line. One that not only replaces off-the-shelf switches, but integrates them wirelessly. Essentially, a system to sit at the core of any assistive household. Let's take a family in need, using our system with their 6-year-old daughter, Jackie. Now, like many children with cerebral palsy, her switches are a huge part of her life. Her mom has just bought a new toy, which is a bubble machine you can see in the middle. So now we can have a look at how Jackie learns to play with it herself. Jackie's mom has already got our system in her home, so to connect the bubble machine, she first chooses the switch she wants Jackie to control it with. Here, she chose the simple green button. Now, to get it up and running, she places our wireless communicator inside. This is what gives the switch its power and what pairs it to the hub. We can see she's assembling the switch and then plugging it into the power supply so that now it's ready to connect. To set up the bubble machine, the process is even simpler. With a smart wireless plug already set up, she simply plugs the toy in to control its power supply. To connect these devices together, Jackie's mom turns to the user interface. Here, she starts by adding the new switch as a device. So she gives it a name, she calls it the green button, and she fills in all the device details. Once she clicks add, the device is paired, and she navigates to the home screen where she sees a flow dashboard, which is a log of all the existing configurations. So she's clicked create new flow, and she adds the input, the green button. Here, she also specifies how she wants Jackie to use the switch, so the fact that it's held down. She's put in the output, and finally she sent it to the central hub. So now, whenever Jackie holds down the button, as you can see, her bubble machine turns on.
Every time Jackie uses the device, each of those button presses, the action is logged. If her mum or her occupational therapist navigates to it, they can see trends in the usage data and see how effective Jackie is at using each switch in each flow. Now on this page, she can see which switches Jackie is using most, or how often or whereabouts in the house. Okay, so Jackie's mum is pleased with how the system works and wants to add a new switch, one with a custom shape. She navigates to the Access Hub, which offers her the opportunity to order a custom switch, as well as lots of other features which make her feel a part of the community, such as talking with other users and sharing their experiences and ideas. At the Access Hub, she goes to order the custom switch, and here she'll find an optional additional tool that will help her identify the perfect switch to fit her daughter's individual requirements. This is following a similar process to how an occupational therapist would assess the needs of a student, such that this can be done whether or not the family has access to an occupational therapist or a 3D printer. So Jackie's mum then parameterizes the switch to Jackie's hand size, places the order, and now it's on the way.
You've now seen how our primary actors are interacting with our system. We've come a long way since the inception of this idea. What was a sensible way to implement and put this out into the market? Well, here's our three-part ecosystem. Consisting of the wireless unit, the hub, which is a Raspberry Pi, and our dashboard user interface, not only we're decreasing the cost of switches through the wireless unit, but we're making the hub interface interaction more intuitive, and we're letting occupational therapists and students configure the entire system in one globally accessible platform. We're relying on four main facets to make all this happen: reducing costs, simplifying setup, modernizing hardware, and improving accessibility.
Now for the first branch of our ecosystem. To better meet the fundamental goals of switches, we're doing away with the current hardware and rebuilding the switch from the ground up around our new wireless unit, the Woo. We're compacting this most expensive part, which is the hardware, and we're making it reusable, such that this modular communication unit sits at the core of every switch and links wirelessly with our ecosystem. That means that now, to get an entirely new switch, you need only change out a 3D printed casing, which instead of hundreds of pounds, costs pence to the end user.
So our hub is a device that sits in the home or school and controls the interactions between multiple rooms and various outputs. It does this wirelessly and, as you've seen, has quite simple user interface which allows any user to create and modify configurations with ease. These configurations are now fully customizable, no longer being limited by the hardware interfaces available. In future, the community will be able to create and share custom functions and configurations, incorporating existing smart devices such as the Xbox accessible controllers, Google Home, or Samsung smartphones. With thousands of IoT devices available on the market, this access drastically expands the autonomy each user has over their own home, controlling lights, appliances, doors with the click of a button. So, as previously mentioned, the hub can be configured to record usage data, which we believe could help kickstart a new age of therapeutic analysis. Our product puts this data directly into the hands of the occupational therapist, removing the complications found with manual recording, allowing for them to make enhanced insights into the progress and development of each child. In future, this process can then be further streamlined with the introduction of advanced machine learning techniques and data analysis. So this system is built using a lot of different moving parts, but primarily our front-end hub application is built using React.js, which then communicates with a Python API that controls an instance of Node-RED and a MySQL instance on the hub. Our Woo devices, depending on which model, communicate to Mosquito, which is an MQTT broker, either over Wi-Fi or Bluetooth Low Energy. We then use our Node-RED instance to orchestrate these devices via MQTT and send commands between devices.
Now, all this effort means nothing if we cannot put our product into the hands of those that need it most. Using the principles of open source and open hardware design, we know that to sustain a project of this magnitude means walking the line between community and business. This is why we have put great thought into how to bring this product to the market, as not only a competitive switch system, but one affordable and available enough that our target users can get their hands on them.
Looking to the market now, one of the most comparable wireless rechargeable switches costs a staggering £125. Now, in the simplest manifestation of our product, where all 3D printing would be done through third-party services, a single unit costs only £26.66. And if printing can instead be done in-house by us or a charity, that price drops to just £10.66 per wireless rechargeable push button. So as you've seen, this project comes with a unique set of challenges, and one that is important to us is how we can make this system as available and accessible to all. To ensure this, our hardware is to be sold at cost, and our software is planned to be free and open source. This brings the obvious complication of running costs. There is an inherent upkeep that needs to be covered, and crucially, we don't want to make our end users have to foot the bill. And so the model we have proposed is a foundation funder model, where an organisation such as the JS Foundation will support the project financially through a number of sponsor partners. And we drew inspiration from other similar open source projects such as Node-RED, which show that this is a viable option.
Now, we recognize the resources required to build an ecosystem like the one we envision, and this project is larger than the Woo hub and UI that we've created in 12 weeks. This product has the potential to sit at the core of every home, seamlessly integrating IoT and assistive devices alike. We feel that it has such power to give autonomy to this generation of kids, and thus we've spent much time laying out a vision for how to make this the best possible product before it hits the market.
Why does it all matter? Well, we're aiming to offer great access to essential technology for people with disabilities worldwide. And we're doing that at a lower cost. We're also offering better customizability. More children will be able to use switch systems to interact with their friends through an online interface. More users will be able to control house appliances without the help of a third party. Through our solution, we're making life more accessible to those that truly need it. Thank you all for listening.
Okay. Thank you. Perhaps we want to switch as soon as possible to Marwell, so that we respect the schedule. Thank you.
Thank you, Team Pace. You've done a really, really great job over the last 12 weeks, and you can definitely walk away from this project knowing that you've made a huge difference. I want to introduce Marwell. They're working with a conservation zoo locally to Winchester, and I'll pass over to the team to tell you more about their project.
So, hi everyone, we're Team Marwell, and we're really excited to present our project to all of you. So here's our team. I'm Zena, this is Alan and Seon. Our project has been overseen by Dave and Pete, and additionally we've had extensive support from both our technical and design mentors throughout the process. So I'd like to start by outlining the context of our project. So Marwell's mission is to conserve biodiversity and other natural resources on both a local and international scale, and they rely on the support of their customers to do so. Marwell are constantly seeking to encourage understanding and inspire care for the natural world, with the main aim of connecting people with nature. Now Alan will take you through the first problem that we encountered from our discussions with Marwell, and he'll also talk about our solution that solves this.
Thanks, Zena. I'd like to start off by introducing a character we've been working out throughout the course of our project, Milla. She's an 11-year-old Amur tiger, one of the 2 tigers at Marwell Zoo. Her family has recently been under serious threats of extinction, and there are many similar species that zoos like Marwell try to save. But when you're trying to take care of a captive animal, there's a significant need to ensure high quality of life within the enclosures. This is where our behaviorist Julie comes into the picture. She and her colleagues have helped look after the species by regularly monitoring their behaviors and looking out for anomalies and stress indicators. But monitoring these animals requires lots of time sitting outside while staring at the tiger for many hours to get a useful amount of data. At Marwell, they often spend over 90 minutes per day observing the animals, writing down what activities the tigers are doing, and then manually inputting the data into an Excel sheet. And interestingly, they have to do this manual monitoring task for all the animals in the zoo, not just the tigers. This is certainly not ideal for Julie or any of the staff, and this time can be better spent focusing on more important things. So to improve the welfare of animals in Marvel and potentially zoos all around the world, we've created a solution where we're completely automating and even improving the behavior tracking task of animal experts and behaviorists. We've tracked behaviors of the animals and their locations using computer vision and created a dashboard which has all the information required to evaluate the quality of the lives of these animals and consequently give the zoos a chance to optimize it. Now let's assume Milla hurt her paw last week and she can't walk as she normally would. Before our solution, this would have only been identified a few weeks down the line when it could possibly be quite late. But now with our new solution, Julie can just glance through our web application to get more information of the tiger's well-being on a daily basis. So Julie visits the web app and browses through the dashboard. She sees something unusual in the highlight section of the page. Milla appears to have been walking significantly less and grooming much more than usual. So Julie wants to know more, so she navigates to the highlights page, where she sees a sharp dip in the daily walking hours on her right and a steady rise in the grooming just below that. And she's now fairly confident that something is wrong. She then investigates further by navigating to the activity data page, where she again sees a sharp rise in the resting hours and very less walking in the detailed activity timeline. Looking at the weekly timeline, it looks like something might have happened 3 days ago, which is causing this atypical behavior. She then has a look at the movement page and notices that Milla has been moving only in one part of the enclosure today and not very much more over the last week compared to the last month. She can now confirm that Milla might have an injury, looking at how less she's been moving. She can then call in the vet and download a report of the behaviors for further diagnosis, which could lead to a speedy recovery and a very happy Milla. So similar to this case, the web app can also help zoos spot high stress levels in the form of pacing and also spot major deviations from a typical day in the life of Milla. So now Zina will take you through another problem that we encountered from our discussions with the visitors at Marvel, and she'll also talk about our second product that solves it.
Thanks. So I'd like to introduce you all to Daisy. Daisy's just turned 10 years old and she's excited for her birthday trip to Marvel Zoo. Her father John will be accompanying her and looks forward to an enjoyable and educative experience for both Daisy and himself. So after a long car journey, they arrive at the zoo, and their first stop, upon Daisy's eager request, is the tiger enclosure. When they get there, however, they can't seem to find the tigers. And after spending a whole hour thoroughly covering all 6 viewpoints trying to spot them, Daisy is growing increasingly annoyed and unfortunately faces the same experience after exploring the other enclosures within the zoo. This brings us to our first pain point. In the zoo's quest for exhibits that are super beneficial to animal welfare, visitors are frustrated since they are often unable to spot the animals within densely planted large animal enclosures. Finally, both Daisy and her father grow tired of trying to find the animals and they decide it's time to depart. This leaves John concerned that Daisy had not learned anything about the animals that she could take away from the trip, and this brings us to our second pain point. Many visitors often leave the zoo lacking any understanding and empathy towards the animals, something that Marvel in particular desire to provide. So after taking a look at all of this, our team decided to have multiple screens planted around the enclosure, which constantly point visitors towards the best viewpoint for the highest chance of spotting the animals, while additionally displaying infographics that illustrate the behaviors of particular animals. And this enables a more personal connection between the visitors and the animals. So with our solution in place, let's take this story back again and look at Daisy and John's new journey. So on arriving at the enclosure, Daisy's attention is immediately drawn towards which viewpoint she should visit, and she heads over there with her father. Fortunately, she manages to spot the tiger immediately, and her trip at the zoo has already been a success in her eyes. Looking back at the screens planted outside the enclosure, she sees outside each viewpoint. She digests the infographics about Milla and facts about both tigers in the wild and in the zoo. These surprise her and motivate her to speak to a member of staff at Marvel to find out even more. So while Daisy learns more about the animals at the zoo, She starts to develop an emotional connection towards them and asks her father if she can adopt one. Since it's her birthday, John really can't say no. So both Daisy and John are really enjoying their experience, having the chance to not only spot the animals but also differentiate between them. And what's different about these screens, compared to the usual screen one might find at an exhibit, is that they update continually, displaying infographics associated with the current habits and behaviours of each animal, thus keeping both first-time and return visitors engaged on every visit to Marvel. So we've also developed an extensive set of infographic slides that would be updated on a regular basis so as not to bore any visitors, and we would switch between numerous options on each occasion. So Daisy leaves Marwell content that she got to see the animals and connect to them on an emotional level, and John is relieved that their experience was both engaging and educative at the same time. Now on to Seong to talk to you about the core technology that powers both of these solutions.
Thank you very much. So let's first summarize our whole system architecture. So firstly, the video goes through our three-step processing of detection, identification, and behavior classification. Then it's saved at the database in the cloud. Then the cloud function regularly runs to arrange the data in a format that is easier to be fed. And finally, the required data is queried and then fetched by the front-end web server to plot the graphs. So now, to make our applications provide insightful analytics from the video, our program had to be very smart and versatile enough to answer questions like, what is a tiger? What tiger is it? And what is it doing and where? And in order to make this happen effectively and efficiently, our team has used cutting-edge technologies such as machine learning and neural networks to our software so it can detect, differentiate, and know what it's doing. After days of training and improvements in algorithm, we managed to achieve an accuracy of up to 90%. So here are a few video examples of our backend software in action. So as you can see, it can detect the tigers very well. It can detect the behavior such as standing, resting, and walking, and it knows which tiger it is. So once our powerful processor has finished the job of collecting the data, it'll automatically be sent to our database where our web application can pick up and show up on its graphs like this. So once again, in this video, our tiger Milla, she rests for 4 seconds, then she stands still for 2 seconds, and she walks away for 3 seconds. Now, how will this look on the web app and the database? So as you can see, when it's refreshed, first it records 4 seconds of resting. Then if you refresh again, it shows 2 seconds of standing. And then finally, if you refresh again, it records and shows 3 seconds of walking at last. So the same thing happens with the the visitor screen as well. In this example, we can see the other tiger, Bagai, in camera 4. So on the screen, it tells the visitors to go to viewpoint 4. However, once Bagai disappears from camera 4 and it appears again on camera 5 with some food in his mouth, then this update will be shown on the screen, and our Daisy and John knows exactly where to find them. There are a few functionalities that we intended to have, but we had to remove from our MVP, mainly due to time constraints. So let's talk about how our program can be improved. So first of all, now that it works on the videos that are directly taken from the zoo, the next step would be to permanently deploy the camera at the zoo. And secondly, we will capture many more different behaviors of tigers in order to provide much more valuable insights. Also, with the help of night vision cameras, our next step will be to track the behaviors at night, which we believe it'll add enormous value to our project. So we believe the scope of this project covers a much wider spectrum than we have touched within the last 3 months. So we believe the same technology can be applied to all the animals around the zoo. We believe with the collection of enough data, the computer can detect all the issues of animals at the earliest from the hint of very subtle anomaly from their behavior. So not only in the zoos, but also the technology can be applied to wildlife animals where collection of big data in their natural habitat would benefit the research and it can be utilized for conservation of biodiversity, which is a very big problem here. And then If this project was to be extended as far as it could reach, we strongly believe that it would have a significant impact in getting to know the animal and wildlife better. Thank you very much.
Thank you for listening et merci pour votre attention.
Thank you, Team Marwell. That was an awesome presentation, and I hope the audience can appreciate that you've only been to Marwell Zoo only a couple of times, so you've done really well considering that you've been virtual in this situation. So well done to you. Last but not least, from Team UK, we move on to Team Footprint, who are looking at sustainable fashion.
Hi everyone, we're Team Footprint from the UK, and we've been working with Burberry over the last 12 weeks to build a solution around the sustainable fashion domain. But before we show you all the work that we've been doing, let's meet the team. So hi, I'm Nikhil. I do computer science at Durham University.
Hi, I'm Eleanor and I study physics at the University of Exeter.
Hi, I'm Sergio and I study computer science at the University of Southampton.
And I'm Tara and I study engineering at the University of Oxford. So today we're going to be taking you through what we've been working on over the summer. We'll start by introducing you to Jack, who is a persona that we've been using to help us get an insight into what customers want from retailers at the moment. We'll take you through a demo of our solution to his concerns, and then you can ask any questions in the chat afterwards.
So this is Jack. He's a 30-year-old patent attorney and he likes high-end fashion, but he's also very concerned about sustainability and the impact that he's having on the environment. And he wants to buy a coat, so he goes shopping, but he can't find any sustainability information at any of the brands that he usually shops for. So he goes on the hunt to find a brand that does have this information and that he can easily understand and trust.
We can summarize Jack's concerns into 3 main points. So first of all, he wants a brand that he feels aligns with his values on sustainability. And quite a few brands do give sustainability information, but they don't always show transparency or any proof for the data they're showing. So he feels it's difficult to trust these brands. And he also wants a quick and easy way to understand the impact of the purchases he's making.
So with Jack's concerns in mind, we looked at what other brands are doing in terms of kind of highlighting their sustainability efforts. And one company that stood out to us is Rapa Nui. And after a discussion with their co-founder, Mark, we found out that they actually showcase sustainability mainly through a map on their website, which shows the journey of an item from farm to store.
We had lots of different ideas when we started the project, but after discussions with Burberry, we decided to focus on improving their customer experience when they're in store. So our solution is Voyage. Voyage is an app that can be downloaded by customers, and when they are in a Burberry store, they can scan any item in the store to find out more information about it. So they'll first find out about the sustainability information, so this will give them a quick guide to whether this product aligns with their values.
They also have access to a timeline, which basically shows a list in chronological order of all the events related to an item. And they also have access to stories, which give more details about them. But then customers can also add their own events and stories, giving them a more personal connection with the item, but also adding more information that potential second-hand buyers can access, which will keep the resale price up, which gives Jack just another reason to make the initial purchase.
Let's catch up with Jack. Winter is coming and he's looking for a new coat. So he heads into a Burberry store, and while he's in there, a sales associate comes up to him and tells him about a new in-store experience that they have. So he downloads the Burberry app and discovers Voyage.
So Jack opens up the app for the first time and he's presented with the login screen. And since he's a new customer, he taps on register and that takes him to this priority selection screen. Here he can select up to 3 sustainability priorities that align with his views. And this information is used later on to personalize his experience. So he submits the 3 that most align with him, and that takes him to the wardrobe page.
There's nothing in his wardrobe at the moment because he hasn't bought anything yet, but he can tap scan QR to find out a bit more information about the coat that he's looking at the moment. So that then takes him to that coat's attributes page. So the green bubbles are the positive attributes for the coat, and the larger bubbles are the attributes that align with the priorities that he selected earlier. And all of the data that you can see on this page is just example data for the purposes of the presentation and doesn't actually represent a Burberry product. So here, there's under the relative tab, the numbers are relative to the lifetime of the item. So Jack can see that by using the slider at the bottom, that by varying the amount of time that he keeps the coat for, this changes the numbers. And then under the equivalent tab, these are the numbers in more relatable terms. So for example, the water used is in terms of number of bathtubs. And then finally, at the bottom of this screen, he has some suggested items that also align with his priorities.
Yeah, so Jack now wants to find a bit more about the coat that he's looking at. So he taps on the go to timeline view, and that takes him to the event timeline. And here he can see all of the manufacturing events that have happened prior to the coat getting to the store. And obviously something like a trench coat is a really complex item. So he also has the option to filter by the components that make up the coat and just look at the events for each one. All of these events also have a story behind them. So if he wants to learn a bit more about the farming event, for example, he can tap on its event card, and that takes him to its story. And this, the story cards, he can swipe through and find out more about what actually happens during this manufacturing stage. And he can also find out information about the initiatives that Burberry have in place to improve the sustainability. And maybe he also gets some information like about the farmers and other individuals involved.
And then back on the timeline page, Jack sees that there's an alternative map view. So this view shows all the events for the coat in terms of where they've happened in the world. So the countries highlighted in green are countries where events have taken place. So he can move around the map and select a certain country that he's interested in, for example, France, to see the events that have happened in that country.
So Jack's been really busy at his new job and has bought quite a few Burberry items since the last visit in store. But he also had a wedding, and at the wedding he wore a Burberry tuxedo, and he wants to add a picture of himself wearing that on the item's timeline. So he opens the Voyage app, and then I'll let Elena take it from here.
Yeah, so as Sergio just said, Jack is now a loyal Burberry customer, so his wardrobe is now filled with all the items that he owns. So he can tap the tag on the corner of any of the items to take him to the aftercare page. And when he does this, he can see a digital version of the tag he would have seen when he was in the store when he bought the item originally. So he can flip through the pages to find out how to best care for his item and how to make it last as long as possible. And then he taps back to go back to the wardrobe page.
And now to add the event to Jack's tuxedo, he taps on the tuxedo picture, and that takes him to its timeline. And in the top right, he can tap on the plus button, and that takes him to the add event page. And here he can fill in all the information about the event. So in this case, it's a photo, and he can put in the description and location. And finally, he can select the image. And he has the option to take a photo now, but he's actually already got the photo in his library. So he goes and finds that, selects it, and finally taps on submit to add it to the tuxedo's timeline. So this not only adds it to the timeline, but in the background, we have a blockchain that also records that an event has been added. So if Jack scrolls all the way to the bottom of the timeline now, he can find his picture event. And as you can see, it's got a bold outline. And this just means that if he taps on it, it has a story, and he can find the image that he's just uploaded. And so that's the app that we've built.
Thanks, Nikhil. So that's everything that we've been working on over the past 12 weeks. And now we're going to talk you through the technology that we've used to build it. So I'll hand over to Sergio to talk you through that.
Thanks, Elena. So this is our system architecture, and you can see that on the right, for our front end, we used Ionic. And Ionic is just a framework that uses JavaScript and HTML and allows us to build hybrid applications, which means that we can write a single piece of code that then can run on both mobile apps for iOS and Android and websites as well. And then in the middle, we have our backend, which uses Node.js mainly because it shares the same base programming language, JavaScript, with our front end. And GraphQL is kind of the glue that helps move information from the backend to the front end as we need it. And on the left side, with all the services, we have the IBM blockchain platform, which Nikhil talked to you about already. But we chose this mainly because it's very scalable for large applications. And IBM Cloud Object Storage holds all of our assets in the cloud, for example, the images in the stories. And for our database, we used IBM Cloud.
So throughout the course of this project, we had lots of ideas about how we could develop this in the future that we simply didn't have time to implement in 12 weeks. So we're going to talk you through a couple of our key ideas now.
So quite early on in our meetings with the Burberry team, it became apparent that store assistants are really important in the customer's experience. So we want to possibly have an iPad version of the app, which would give store assistants the tools not only to kind of educate the customers, but also to drive potential sales by using past purchase history of customers and their sustainability priorities.
Another development would be a resale platform for Burberry items. So customers like Jack would be able to browse through secondhand items and know that the items that they're looking at are authentic and have been well looked after because they'll be able to see all of the events on the item's timeline. And this promotes circular fashion and would help Burberry to expand into a new market.
So that was a very quick overview onto what we've been working on over the past few weeks. Thank you all for listening, and we'd also like to say a huge thank you to all our mentors who've been invaluable during the internship. If anyone has any questions, please put them in the chat and we will answer them in a minute.
Well done, Team Footprint. You've done really well there, and you've impressed the client and the internal IBMers so much that they are taking this project forward with IBM. So well done. And I'll pass over to Thomas, who's going to introduce the French team.
Yes, I should say we should really thank the UK team as a whole, because it's really exciting project that you've shown us. I know a few people in the audience, and I know some of them will be interested by PACE and by the sustainable fashion project, and well, Marwell I know less, but very exciting project. The French project is called CAVERN, and it's a philosophic reference to the Plato's cave. But I will leave, I guess it's Rida, introduce this project. And by the way, we're just on time, so that means we may have a few minutes for questions. Thank you, Rida. You can.
Thank you, Thomas. So hello, everyone. Thank you very much for being here today. Our Extreme Brew project is actually research-oriented, and it is dealing with human and computer interaction in the context of decision-making processes. Next slide. So we are a team of 4 students at IBM France Lab in Paris, and we come from different backgrounds. First, there is Manon and Guillaume, who study applied mathematics and statistics. Victoire, who does a Master of Management of Innovation. And finally, me, who does a double degree program between an engineering and a business school. Now, I will let Victoire introduce the project.
The technology we are dealing with in this research project is machine learning, and we focused our research on its use in decision-making processes. There are 2 main concerns regarding machine learning drawbacks. First, the flaws of the algorithm coming from the database provided to it. Then, the way people interact with the algorithm, especially when it gives wrong recommendations. Our work is not focused on databases flaws, but rather on the interaction between a human user and the ML-based recommender. ML-based algorithms are already used in decision-making processes in order to help them. We have studied the interaction in order to understand the phenomenon of collaboration that is created between a human user and the ML-based tool. And we are going to present you with our findings. Here is our goal, measuring the impacts of recommendations provided by an ML-based algorithm on the rationality of someone making a decision. So, to study human-machine interaction, we launched an experiment where each participant had to answer 20 questions. The participants were randomly assigned to the control group or the treatment group. In the control group, the subjects were asked to answer the 20 questions without any recommendation from an algorithm. Whereas in the treatment group, they were asked to answer the same kind of questions, but this time with a recommendation from an algorithm. So the participants in the treatment group were assisted during the whole experiment. We want them, for the treatment group, by following the recommendations, the score would be on average 77 out of 100, or about 15 out of 20.
So to make it simple, the first hypothesis we wanted to test, which is called H0, the recommendation does not have an impact on the subject rationality. So of course, if we reject this hypothesis, we have to accept the alternative one, which is the recommendation does have an impact on the subject rationality. But as you know, rejecting H0 doesn't give any information about the way the recommendation is impacting the subject rationality, but we will look at this aspect later with econometric models. So let's go back to H0. To test H0, we use two statistics models. So the first one is pretty simple. It's by considering that all the answers are independent, and so we can use the Bernoulli variable. And the second model, which is a little bit more complicated, is by considering that everyone has a degree of rationality. So float P between 0 and 1, 1 if you are the most rational person ever. So which is a continuous density model compared to the first one. And both statistic models reject H0 at 5%. So at this point of the internship, we made sure that the recommendation is not neutral in the subject decision-making processes. So the next step was to study the correlation between the subject answer and the recommendation. So to do that, we've used an econometric models, and we have looked at two particular events. So the probability, we wanted to quantify the probability of those two events. The first one is called the authority bias. So the authority bias, this is the probability that an individual who has a false recommendation in their interface will make a non-rational decision, knowing that if that individual has no access to that recommendation, they would have made a rational decision. So this probability calculates the way you are changing your mind in a non-rational way. The second event we want to calculate the probability of, this is the resistance of the subject, which is the probability that an individual will make a rational decision when they access a false recommendation, knowing that if the recommendation had been correct, they would have made a rational decision. So it calculates the probability of staying rational with a false recommendation. And so by using an econometric model, we were able to say that the probability of those two events are significantly different from 0. But before presenting you the result and giving you order of magnitude of what we just defined, let's take a look at the website Guillaume and Victoire designed for us.
So thank you, Manon. So to make the experiment that Manon just described to you, we first needed to build a platform. So given the current situation with the coronavirus and our need for quite a large amount of subjects, we decided on building a website. It would first allow us to reach many people easily, but more importantly, maybe it would allow us to measure many parameters very precisely. Those parameters concretely regarded time, how much time someone spent making a decision, how much time someone spent thinking about the problem. To build our platform, we used modern technologies like Node.js, and we were hosted on IBM Cloud Server. Slide, please. So we wanted this experiment to have clearly defined steps, each one with a different goal. The first part was simply a presentation of the experiment. We told the user what he would have to do, and we shared with him our general goal. This is also where the user gave us his general profile, what were his studies, what was his age range, etc. Then what you see on screen is called a tree map. It was a tutorial that made the user understand the dataset better. We gave him relevant information, depending on what group the user belonged to, and it was an interactive way for the user to understand the dataset. We allowed him to tweak the parameters of this tool, and it allowed us to spark interest in the dataset and hopefully make the user make better decisions. Slide. In the actual body of the experiment, the user had to take a series of 20 small tests. On each one, 3 steps were imagined. In the experiment that you maybe took, there were 2 groups of experimentees, each one with a different interface. So the first interface was the one that you are seeing right now on screen. It was the interface of the experiment group. It has 3 parts. The first part is the data on which you have to base yourself to make your decision. Then you have the recommendation from the algorithm, and finally you have the part where you make your decision. For the second group, so the control group, the interface was strictly the same, save for the recommendation of the algorithm that was not there. Lastly, once the user had made his decision, he has to give us some feedback. He had to self-evaluate and give his impression on the algorithm. By giving those questions, we could get an idea of how close of an interaction the users and the algorithm might have had, and how much the recommendation might have influenced the decision. At the end of the experiment, we got around 500 participants. It was a population that was large enough to allow us to outline some interesting statistical effects, and I'll let Rida and Manon present them to you.
Thank you, Guillaume. So one of the first model's results, as you can see, the control group has an average of 72% of correct answers, while the group with false recommendations has only 67%, and the group with true recommendations is up to 79%. Also, as the previous test rejected the hypothesis H0, we have the following conclusions. With the proportion of false and true recommendation, the treatment group performed better compared to the control group and the algorithm. Therefore, we can say that there is a collaboration between human and machine. Secondly, the recommendation is affecting the subject rationality. And finally, subject rationality is more variable with the false recommendation, whereas subject rationality with true recommendation has the same variance in the control group and the group with true recommendations. I will let Manon talk you through the rest of the results.
So then regarding the econometric models, you have 2 types of results. So the table on the left are results similar to what Rida just said, but it's in probability, not in percent. So for example, if you are in the control group, the probability that you give a rational, that you take a rational decision is 0.72. And if you have a false recommendation in your interface, this is 0.72 minus 0.04. So this is exactly the same result, but what's is interesting with econometric model, this is the table on the left, on the right side, sorry. You can see the authority bias and the resistance of subject in probability. We were able to calculate those probability by category. We have choose to show you by age, and as you can see, young people perform best as they have a low value for authority bias and a high value for the probability of resistance. You have to know that the experiment we've presented just here is only one part of what we have done. We have made other experiments to improve those probabilities, especially to lower the authority bias and make the probability of the authority bias lower, and the resistance of the subject higher. And we are actually doing a research paper on that.
Thank you, Manon. So the experiment we have launched concerns a specific bias with the specific parameters. But if you want to take the results of the project further, we can think of different use cases where we use the recommender systems, like auditing, CV screening and hiring processes, loan granting, and deciding of a prison sentence. All of these use cases use a recommender system powered by AI, and we need to ensure the rationality of the users. Therefore, we can suggest for corporations to implement a testing methodology for interfaces that use machine learning recommenders in order to minimize the authority bias that we can quantify with the probability P and maximize the user resistance that we can also quantify with the probability Q. In other words, the interface will be given arguments or some transparency that allows the users to make their own judgment while taking into account all past decisions. Next slide, please. So thank you so much for your attention, and we hope that that the topic has raised some interest and that you have enjoyed the presentation. Lastly, we want to thank again IBM France Lab for having us as interns during the summer. And if you have any questions, please contact Thomas Boudel in the email address on the slide. Thank you.
Thank you. Clap my hands for all the students and all the presentations. It was great. Thank you. Thank you to all of you.
And can I just say, Thomas and Sebastian, thank you so much for organising this expo, albeit virtually. I know we've had a bit of a, it would have been lovely to have travelled over to France. And I just need to add quickly that I did say about Burberry taking the project forward, but this is unconfirmed and not kind of in writing or anything like that at the moment. So it's just a hope, but we don't know if that's actually happening. But I just want to say thank you so much, Sebastian and Thomas, for organising this whole event. Thank you.
You're welcome. For all of you, I have recorded this presentation, the full presentation, so we'll be able to push a replay sure after a validation from all the teams into our YouTube channel. So thanks all of you. Thomas, do you want to say something?
Well, yes, if you can move on to the next slide.
Oh, sure.
So we know that it's a little bit frustrating that we can't make room for for a few questions after that, because I have some questions and I refrain myself from asking them. And I'm sure all of you have some. If you have the next slide.
Should be shared. Yeah.
Okay. Anyhow, this presentation has been recorded and will be available on the YouTube channel, IBM Meetup YouTube channel. And also on the next slide, yes, we have left some contacts that we will share with all the people who address. So we will send perhaps a very short email or simply a message where you can reach the teams for each of those projects. And of course, I know there are some students among the audience. If you want to apply for an Extreme Blue internship in the UK or in France, so you will have links and indication of how to proceed. I don't know, Francesca, are the applications open for next year, or what is the time frame?
No, they aren't open at the moment, but you can still go onto the website, register your interest, and then you'll get a notification when they are open.
Yeah, it's the same for us. Usually we start to think about the program around November. Okay, well, then thank you very much, everybody, and hope you enjoyed it, and hope to see you soon on the IBM Cloud meetups.
Merci à tous. Thanks a lot to all of you, and have a nice end of day. Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye-bye. Thank you.
Bye.
Bye.
Thank you.
Thank you.